So let's take a look at example number 5. Now in your notes, you will notice that you don't necessarily have this Z-score table. I've inserted it in so that I can use it to kind of represent, but don't worry too much about that. We can understand this without the Z-score table. I just use it to give us a little bit of a better visual of it as well. So let's say that the heights of people among a certain population are approximately normally distributed. Now, the normally distributed part is the important part. If we use that, we can use Z-scores to understand certain things. The mean of the distribution is 170 centimeters, and the standard deviation is 5 centimeters. So what that means is here at the mean, this is going to be 170, and then we're going to go up by 5s every single time. So this will be 175, 180, 185, 165, 160, 155. Okay. Now the question is, what is the probability that a randomly selected person will have a height that is less than 172 centimeters? Well, if we take a look at this line here, this is 170, this is 175, so 172 is probably going to be right about here. Okay, it's going to be right about there. So that's going to be our 172, and I'm just going to make this a little bit smaller here so that I can actually write it in. So this is where we have the point 172. Okay, 172 centimeters, I realize that's a little bit bright, but those are 172 centimeters. And so we're looking for what is the probability that a randomly selected person out of this total will be less than 172 centimeters. What that means is that we're looking for this section right here. What is the probability that someone lands in this section right here, all the way up to that line? Well, the first thing we need to know is what is the Z-score of that person. Okay, so we want to find what is the Z-score of that person, and we use our Z-score formula to find that. So whoops, Z is equal to X minus X bar, and I'm going to quickly type that in there. Divided by standard deviation. Now I need to put the brackets in just so that it actually works as a formula on here. You don't have to put the brackets in normally. When we plug the information that we know in here, and I'm not going to use units, I probably should, but I won't. We have 172 minus 170 divided by a standard deviation of 5. And maybe I can quickly switch them in. There we go. Yeah, they do fit. Okay, so we put them in there. Sometimes use units, sometimes not. Just sometimes it takes up a lot of room when I'm typing it out like this. Now, when we calculate this here, okay, we can calculate it. It's 172 minus 170 divided by 5. We're going to get a Z-score of 0.40. Okay, so this gives us a Z-score of 0.40, which is in between 0 and 1. And you can probably kind of roughly see that it would be right about that 0.40. Now, if we go to our Z-score table and we go down to the positive side, and I need to get rid of some of these lines here again. Okay, so we go to the positive side, and we're going to take a look at 0.4, which is right here. Okay, 0.4. And then we look at the 0 side as well. So 0 is right here. So we're going to take a look at this one right here. So our probability that we're given here is 0.6554. So our probability is 0.6554. Okay, that's our probability, which translates into 65.54% of the population. Okay, therefore, okay, so, and we can, if we multiply that by 100, remember we get 65.54. We're just moving the decimal place over one time. Okay, so 65.54% of the population will be under a height of 172 centimeters. Okay, so that's what we're asking. We're looking for that probability. We're looking for the percentage. Probability can be written either as a decimal or as a percentage. Both of those work. Both of them give a probability. So to find that, we need to determine first, what is the Z-score? Second, that Z-score, what probability is associated with the Z-score? Okay, what probability is associated with the Z-score? And remember, this probability is always the one that is less than, not bigger, always less. So it's always to the left of our probability line.